came up with this regulated risk data lake product. This is going to be a repository for large quantities and varieties of data, both structured and unstructured. So usually the data journalists or the programmers can tap the stream of data for real-time analytics. So the risk data lake concept what we have come up with can serve as a staging area for data warehouse, the location of more carefully treated data for reporting and analysis in batch mode. So the data lake usually accepts input from various sources and can preserve both the original data fidelity and the lineage of data transformation. So usually the data models emerge with a huge usage over time rather than being imposed upfront. So the data scientists use this lake for discovery and ideation, and they take advantage of the commodity cluster computing techniques for massive, scalable, low-cost storage of data files in any format. So once after this usual initial data lake concept is built, the data lake load extracts the data irrespective of format into a big data store. Metadata is decoupled from this underlying data and stored independently, enabling flexibility for multiple end-user perspectives and incrementally maturing semantics. So once after this Hadoop distributed file system is built for different input files and output files, and the map tasks and reduce tasks are built. So the Hadoop stores and preserves the data in any format across a commodity server cluster. And with Yarn, Hadoop now supports various programming models and both near real-time and batch outputs. The system splits up the jobs, distributed processes, and recombines the cluster that can scale thousands of server nodes. Basically, it's a very phenomenal scientific modeling stuff which we are helping few large banks with. The data lake foundation includes a big data repository. So we use Hadoop a lot for this, and an application framework to capture and contextualize the user feedback. And the increasing value of analytics is then directly correlated to increase the user adoption across the enterprise. Usually the maturity of this regulatory risk data like what we are putting together may be very less. Initially it may be just consolidation and categorization of raw data, and then eventually we can get to the next maturity level by having attributes on the metadata tagging and linking, so where we will be able to build a lot of joins. So the next third level of maturity, we will have a lot of data set extraction and analysis. On the fourth level, where we'll be able to have business specific data tagging and synonym identification analytics. Let's take an example. Monetary Authority of Singapore, Hong Kong Monetary Authority. These guys from the different regulators of these different regions have a different need of data from a bank like United Bank of Switzerland or Societe Generale. So, and how the chief risk officer will be able to pull out this multiple data from the different disparate data sets which is lying across the thousands of servers of the organization. So how they will be able to do that in a GC? So which they can do it with the help of our risk regulatory data lake concept, the solution what we have put together. So the ultimate maturity level, the level 5 maturity level of our regulatory risk data lake will happen when there is a convergence of meaning within the context. So the meaning within context can be obtained for any of these complaints like NAS complaints, HKMN complaints, or any RBI complaints. A global bank when they are operating in multiple regions, so this can help them. So this can certainly increase the usage across the enterprise of multiple data which is relevant to risk, and increasing variety of value of this analysis also can happen by having this.